Hey everyone, Mr. Kaczynski here, working through IXL's 8th grade math skills, section Q. Today's video is very similar to the last video I created, side lengths and angle measures of similar figures, where the last one was side lengths and angle measures of similar triangles. Same thing applies here. The first thing we have to know is that similar shapes have congruent pairs of corresponding angles. So I could look at this shape down here as a rotation and a translation of the other one, followed by a dilation. So we can see that that angle measure matches up perfectly, as do the other three, but really the only one we care about is that one with a question mark. So we can see that this missing one down here has an angle measure of 148, just like that one up there. All right, you obviously don't have the ability to maybe trace the shapes on the screen and move them around. So what's another strategy we could use? Well, on one like this, I could notice, oh, this is 90 and this is 90. So is this one and so is this one. This angle right here is an acute angle, as is this one down here, acute meaning less than 90 degrees. And this one is an obtuse angle over 90 degrees, so is this one. So this one must be 104 degrees. So you can inspect the shape a little bit like that and use it. I don't think you're going to have too much problem with that. All right, we also need to know how to find missing sides. So what is this value of y? Well, I could quickly look at it and identify that, oh, this side corresponds to this side over here on this similar shape. They tell me that they are similar. So I'll set up a ratio of y to 4. And then I'll create a proportion because I can also go back to this shape, the smaller one, and say that this side is corresponding to that side, so 1 over 2. So this reads y over 4 equals 1 over 2. So you might look at it and go, oh, this is how I would look at it anyway. 2 times 4 is, or 2 times 2 is 4, and 1 times 2 is 2, so the answer is 2. And that would be right. I'm going to look at it a slightly different way today. I'm going to look at it like this with cross products. That's the way I did it on the last one, was with scale factors, but I'll do it with cross products today. Y times 2, that's one cross product, is equivalent to 4 times 1. That's the other cross product right here, 4 times 1. So cross products are always equivalent in a proportion like this. So we could say that 2y equals 4, and then when you divide both sides of this equation by 4, or by 2 rather, you get 2, or 2 kilometers. So we're going to use cross products today, a little bit different than the last video. Let's do this again. All right, I've got this side t, and it corresponds to this side 27. So t over 27 is equivalent to 84 over 63. All right, 84 over 63. So now I'll do cross products, and I'll say t times 63 equals 27 times 84. All right, t times 63 is just 63t, and 27 times 84 is 2268, or 2268. And then to solve this equation, you just divide both sides by 63, and 2268 divided by 63 is 36, and that measure is in kilometers this time, so 36 kilometers. One more. Couple similar shapes. We're told they are similar. These two shapes are similar. So that means we can set up a proportion. We can say V is to, and the tough part here is identifying which side it's similar to. I see a right angle here and a right angle here, right angle here, right angle here. So I know that it corresponds to that side. So I'm going to say V is to 14 as 66 is to 21. Remember that when you're setting for proportion, if I'm going big shape, small shape, big shape, small shape, to set it up properly. All right, if we use cross products, I'm going to say V times 21 equals 14 times 66. Okay, V times 21 is just 21V, and 14 times 66 is 924. To solve this equation, you just divide both sides by 21, and 924 divided by 21 is 44. And this time we're measuring in miles. IXL puts the measurement in there for you, so all you have to do is type 44. All right, so that's side lengths and angle measures of similar figures. Let me know how it goes in the comments. Good luck.